All right, if given the molar heat of vaporization, the molar heat of fusion, and or the specific heat, I can calculate how much energy must be added to a substance for it to undergo a phase change. This is called thermodynamics. It's a whole branch of chemistry that tries to explain how much energy is involved whenever there is any kind of physical or chemical reaction. Definitions time. What is heat of fusion? The amount of heat energy needed to melt 1 mole of a solid substance. As soon as you write that down, start thinking about melting and the word fusion, and see if it bothers you as much as it bothers me.
Oh, that bothers me. I get it.
It doesn't bother me.
Okay.
I don't know.
Mr. Moreno, Via here says that these two sides are the same.
Yes, I'll let you do one side. You don't have to do the other.
Oh, you're that guy?
Okay. Mark, why does it bother you?
Because if you're like melting something, it's like in some part.
Exactly. When you think of melting, you're thinking about as they become liquid, they spread apart. But fusion is actually coming together. So why did they come up with this contradictory term? Because the first time they defined heat of the melting of water, what happens to water when you melt it?
It freezes. I mean, sorry.
It
It
comes together. It comes together. Remember that water takes up less space than ice. So the term was originally used to describe what was happening with water. Unfortunately, what water does, only water does. And 99.999999% of all substances actually spread out. But the name stuck. So we're stuck with it. Heat of fusion is how much energy is needed to melt 1 mole of a substance. Since water is what we're going to be dealing with most of the time, 6.02 kilojoules per mole is your heat of fusion. No, I will always give it to you in one form or another. The symbol for heat of fusion is delta HOF. It's not an O, it's actually a degree sign.
Is that
So is it measured in Fahrenheit?
It is measured in kilojoules. Fusion.
Oh, okay.
Fusion. Heat of, it's not really of, but it's like a little degree symbol. Okay, the other definition word, which this time it does make sense, heat of vaporization, is the amount of energy required to boil 1 mole of a liquid substance. Boil 1 mole of a liquid substance. For gas, for water, it's 40.7 kilojoules per mole. So, what is the heat of condensation for water? What is the heat of condensation for water?
40.7?
Yes! Because what is condensation? The opposite of vaporization. It's the same thing, but whereas this is the heat of vaporization, this is the heat of condensation. Because to condense something, you have to take away its heat. You have to make it give up its heat. Negative, positive. What is the heat of solidification? What is the heat of solidification?
Hold on.
Same thing, opposite sign. Because what is solidification? Freezing something. What is fusion? Melting something. So, do not let the words confuse you. But I will always give you the heat of fusion. because if you know the heat of fusion, you know what the heat of solidification is. I will never give you the heat of condensation because it's the same thing as the heat of vaporization. Different sign. Now, did you notice the difference between 40.7 and 6.02?
6.76.
Wow. Why is the heat of vaporization 7 times greater than the heat of fusion? Yes, Ryan.
Because they take the energy with them once they turn into it.
If I melt you, where are you going to take the energy? If I melt Elizabeth, where is she going to take the energy? Probably over here in order to talk to Alice. What happens to Allison's energy when Elizabeth bumps into her? So the energy stays with the liquid because they can't get very far. But what happens if I vaporize Elizabeth? Where does she take the energy? Wherever she goes, and she goes away. What happened to Allison? Allison got left behind. So I'm going to have to add even more energy in order to vaporize Allison. When you melt something, you loosen the bonds. When you boil something or vaporize it, you break the bonds. Break the bonds. All right. There are 2 types of questions. Well, actually, there's some in between. But I'm going to give you 2 extremes. 2 examples. One is easy peasy lemon squeezy. The other one is hard, fard, lard, tard. I don't know. All right. I give you little things to remember to help you. When you go side to side, you need to remember to use train tracks. When you go up or down, you need to remember to use the Q equation.
Is that like really up or down or diagonal?
That's up and down. All right. Why do I have it in those angles? Because everything is based on the heating curve. All these questions are based on the heating curve. Calculate the energy required to melt. Where is melting here? Let's see. 1, 2, 3, 4, 5. Where's melting? So you're required to melt 8.5 grams. So you're going to have to take 8.5 grams and make it melt. So you go from 0 to 0, but from 0 solid to 0 liquid. So you're going to go from 0 degrees solid to 0 degrees liquid. That's melting. So, what technique do you use to solve these questions? Which number should you begin with? You have 2 numbers, 8.5, 6.02. One is a fraction, one is not. No! I have never told you to use a fraction first. It is the other way around. Never, ever, ever start with the fraction. All right, here we go. We're in grams. What unit do we need to solve for? What is, okay, joules, or either one will work. Do we have a conversion of grams to kilojoules? No. But we do have a conversion of kilojoules to moles and moles to kilojoules.
So we gotta get it to moles.
Where there's a mole, there's a way. Can we convert grams to moles? Moles? Bang!
Oh, please stop. Not really.
Grams.
Formula mass.
And what is the formula mass of water?
H2O.
Yeah, I was right.
Now, we have things in terms of mole. Can we use something to convert moles to kilojoules?
No, there's some joules though.
Your phone's on you.
Oh, that.
Bring it.
That's not nice.
Yes. Yes, yes, yes.
Great.
Marielle, 5 minutes before the bell rings to scoot on out to the guidance. What's the answer?
45.
Which one, joules or kilojoules? 45 kilojoules.
Is that actually right?
Yeah.
Okay. That is easy peasy lemon squeezy. You've already done the ones that you can do this because those were Q equations. Okay? Now you can do side to side. If you're up here, will you use 6.02? No, you will use 40.7. Okay. This is as hard as they get. I'll give you a chance to copy down the question.
We have to copy down the question?
You don't have to copy down anything. If you want to copy down the
Take a
question,
picture of it with my phone?
sure.
Oh, we can use our phones. Yep.
All right. 25 grams of ice. First of all, what are all the different parts to this? 1, 2, 3, 4, 5. If you're ice, where are you?
2.
No, that's okay. That's okay. He's right. It could be at 2. 25 grams of ice at negative 15 degrees. C, where are you? You're somewhere here. So we're starting life here. We need to go to steam at 110. So our journey begins here and needs to go here. How many steps does our journey have?
2.
1 gets you to the cusp of melting. The second step gets you to liquid phase. The third step heats you up to the very cusp of boiling. Then you have to boil. And then finally you take all that steam and get it to 110 degrees. Folks, this is 5 steps. Most chemical and physical reactions take place in multiple steps. For example, Krebs cycle. I can give you the general formula, C6H12O6 plus so many oxygens yields, I think it's plus 6 oxygens, yields 6 CO2s and 6 H2Os. Does that happen in one step?
No.
You learn from biology that happens in multiple steps. So how do they know that that much energy is released? Because they use Hess's law. Hess's law states that if you have multiple steps, what you have to do is add the heat of step number 1 to the heat of step number 2 to the heat of step number 3, etc., etc., etc. So how many steps do we have? 5. How do we find the final answer? Add all 5 steps together. All right. Step number 1, up and down or side to side? Up and down.
Oh my
So
God,
we're
this
going
is gonna-
up.
This is going to use both equations.
Yeah.
Oh my god.
So which equation do we use to go up? Q equation.
Yeah.
Q is equal to mass, which is 25.
Oh, is this like the metal?
Yes.
Where's 20?
Times what is
125.
15 to
times the change in temperature. So what is the change in temperature? Where do we start? Negative 15. And where do we go? Negatory. Step number 1 goes from here to here. So a difference of 15 degrees. Times what? No, that is the specific heat of water. You need the specific heat of ice. Look at your worksheet. 2.06 joules per gram C.
This is a lot.
Go, calculate.
Wait, do you have to do this for every step?
Yes.
Wait, is that, do we have to do this on our homework?
Yes. I told you, some of these are easy peasy lemon squeezy, others are hard, fard, dard, and tard.
How long do we have to do this? Tomorrow?
Till tomorrow, yes. Who's got it?
772.5.
No.
Plus.
No.
Wait, I'm going to murder you, Grant.
Okay. She made the most common mistake that people will make with these things. She left it in joules, especially after I asked her to convert to kilojoules. So she was right. 772 joules is 123.77 kilojoules. And remember Sig Diggs, Alex's favorite thing. Okay, are we done? No, we're only 1/5 done. Step number 2. We're going from here to here.
Train tracks.
Train tracks. We begin with 25 grams. What are we going to have to convert grams to?
Moles.
1 mole is equal to 18 grams. Now, what do we convert moles to? And which one do we use? We have 2, 6.02, and we have 40.7. Elizabeth. Yes. Heat of fusion. We're trying to melt it. 6.02. Go.
Is that 1 mole on the bottom?
Yes.
What do you do with all these things?
You'll see.
This was already.
8.4. Why are you wrong and I'm right? Why are you wrong saying 8.36 and I'm right saying 8.4? How many Sig Digs?
6.0 or 8.02.
Now we need to go from melted water, which is very, very cold, to very, very hot water. What equation do we use?
Q equation.
Mass? Same mass. Change in temperature, you're going from what to what?
0 to 100.
Now, do you know the specific heat of water?
Yeah.
You got it right this time, Natalie?
10,150?
No.
Point
No.
1,050.
10. It's 10. Right? 'Cause you have 6 okay.
10,400 is, move the decimal place, 3 places over, 10.4. Incorrect Sig Digs, it's 10. Step number 4, you got very, very hot water. You need to turn it into steam. Side to side is?
That's a train track.
But this time, Elizabeth is not going to use 6.02. Elizabeth is going to use...
40.7.
Elizabeth? Because that is your heat of vaporization.
I feel bad for people who have to do this on a regular basis.
They have computer programs that do that for them.
Why can't we do this?
Because you don't have to do this on a regular basis. In order to get to the point where you have to do this on a regular basis, you have to be very good at regular chemistry. What? 56. Finally, we have to get steam
It's 102.
and make it even hotter.
110, 110. 110 minus 100.
Q equation or train tracks?
Q equation. So it's 25.
110 from 100. Specific heat?
1.87.
Where'd you get 1.87 joules per gram C? Where'd you get it? It's on the worksheet. I will give you those numbers.
Is that grams?
Yes.
0.4 kilojoules?
No.
No.
0.47.
0.5 kilojoules. 0.5. 0.47
He almost wrote joules.
Yes.
I seen it.
Okay.
So what's your final answer?
You did
0.47.
Do you add them all up?
Add. Which law?
Hess's. I used to collect Hess's.
The answer?
77 kilojoules.
Very quickly, what would be, how much energy must be released if you take steam at 110 and take it down to ice at negative 15? It would be negative 77 kilojoules if you go in the
I
reverse.
would have done the whole thing.
Yes?
Wouldn't it be positive 77 that's released though? Like negative 77 is taken in?
No. Positive is going in.
Well, yeah.
Why is it?
The best way to remember is money.
Yeah, why
Is it, hold on, 76?
Yeah.
The way I remember, Max, is money. Is it a positive thing when money goes into you? Or is it a negative thing when money goes into you? It's a negative when money goes out, positive when money goes in. We are done.